Alright, to make it special today, I wore my periodic table t-shirt, but I realized afterwards you probably can't see it because it's usually a shoulders and up shot. Oh well. Solution stoichiometry. Now you know how to do stoichiometry, so let's just quickly remind you of the big picture of stoichiometry. So in stoichiometry, what we've done so far is we've taken something we can measure. Now for us it's always been a mass over here, but anything that we can measure in the lab will work, and we turn that into numbers of moles. And once we know numbers of moles, we turn the numbers of moles that we know about into the number of moles that we're looking for based on the balanced chemical reaction. And then finally we turn those numbers of moles back into something that we can measure, because the reactions, of course, work with moles. We work with things that we can measure. We can't directly measure moles, so we have these things like molar mass and molar concentration, grams per mole and moles per liter, and things like that to help us convert back and forth between moles and measurables. So if we think about what we know for stoichiometry so far, it has been mass to moles, moles to moles, moles to mass. What we're going to do now is mix it up a little bit and include some volumes where we know the molar concentration of a solution. Pretty simple. So if you had a mass stoichiometry question like this one, we know how to do it. Mass to moles, moles to moles, moles to mass. And where we start out with this as our mass of known, our measurable, and we eventually convert it by doing all three steps of stoichiometry into this measurable, this mass. So mass to moles of this to moles of the aluminum chloride, and moles of aluminum chloride to mass of aluminum chloride. And the question, or the answer rather, would look something like that. So I've got mass to moles, and moles to mass, and you'll notice I've got molar masses on both ends. Now what I want you to do right now is take a minute and just look at the units. You can pause this if you want to, but look at where the units are. Alright, I've got grams in the bottom so they cancel out. I've got moles here, and so that moles of sodium sulfate will cancel out, and so on. Really look at the units, and you'll know that's my big thing, is units, units, units. The reason for that is if you get into the habit of looking at the appearance of it, you're going to run into a problem. If you pay attention to the units, it's going to go all right for you. Okay, so solutions. Of course, what we do is we measure volumes. And how do we convert volumes to moles? Is we use molar concentration. So we're talking about, typically we are measuring milliliters, but we want to be able to convert that to liters. And our volume to moles, that's our molar concentration, which is units, moles per liter. Now I sometimes refer to that as molarity. That's an older term, and I'm going to start trying to just refer to it as molar concentration. And then we'll have to remember that the units are moles per liter. And then converting from moles to volume, of course, will be the same thing, the molar concentration. Alright, so here's a reaction, here's a question. Hey, it looks almost the same reaction. What volume would react with a certain number of volume? Okay, so now I've got measurable to moles, moles to moles, moles back to measurable. Well, what are my measurables? Here's one measurable here, which unfortunately got one on the next line, 150 milliliters. That's a volume. And I'm looking for a volume, which means my converting from measurable to moles is going to be molar concentration, moles per liter. So what is that going to look like? That's the same basic plan. How do I get from measurable to moles? Well, my molar concentration, my number of moles is the molarity, or molar concentration, times volume. And then that would be 0.7 moles per liter times 150 milliliters, but that has to be in liters because moles per liter means multiplying by liters. And I end up with roughly 0.105 moles of sodium sulfate. Converting from moles of known to moles of unknown, that's exactly the same. Doesn't matter if I'm dealing with a solution or masses or gases, some other state of matter. Balanced chemical reaction gives us 1/2 of the ratio. Things I know and things I'm looking for give us the other half. And I finish up with 0.07 moles of aluminum chloride. And finally, turning that back into a measurable, don't forget my measurable here that I'm looking for is a volume, not a mass. And I have the volume is the number of moles divided by the molar concentration, or molarity. And I was given that in the question. just like I would be not necessarily given the molar mass, but given a chemical formula to find the molar mass. Given the molar mass, or given the molar concentration of 0.25 moles per liter, and I have 0.28 liters, but I can turn that back into milliliters. Now you don't have to. If you want to leave it as 0.28 liters, no problem, because the conversion is a pretty straightforward thing. And the question just said, what volume? Now, if you like doing the factor label method, you know that I do. It's the one line that some people talk about. So look at my units. All right, I start out with the liters, 0.150 liters. That means liters need to go on the bottom so they can cancel out. Moles go on top. Now this is what I was talking about before, paying attention to the units. The moles are still on top, the liters are still on the bottom. That has not changed. But where the position of it looks different because the 1 is in a different place. It's not about where the 1 goes, it's about where the units go. Now I've got moles of sodium sulfate on top. They're going to cancel with moles of sodium sulfate on the bottom, and moles of aluminum chloride on the top, which will eventually cancel with moles of aluminum chloride on the bottom, leaving me with liters of aluminum chloride. So the units still work out, and the numbers are also all the same as well. And we get the same answer. Now, if I ask the question a little bit different, similar reaction, kind of, I got aluminum in there still. But now I mix it up a little bit because I also know how to work with masses. I can do mass stoichiometry. I just got finished doing volume stoichiometry. What if I combined those a little bit and did a volume going to a mass? Well, the plan of stoichiometry is still the same. Measurable to moles, moles to moles, moles to measurable. The only thing that's going to change is what is my measurable on either end, and how do I get from measurable to moles or moles to that measurable. So in this case, when I'm working with a mass, I'm going to be involving a molar mass, and it'll actually be the molar mass of aluminum hydroxide. And finally, I start with a volume. So now I'm talking about the molar concentration, which in this one I'm still using capital M, and I'm trying to make that conversion, old dogs, new tricks, and that kind of thing. So let's see what this is going to look like. The plan is the same as I mentioned. Reaction again, just to kind of give us a bit of a plan. So here's my molar mass, that's how I convert. Here's my molar concentration, I'm going to use that to convert. Of course, I'm going to have to turn that into liters. And as a one-line method, and you could do this in 3 steps, 3 distinct steps, you would take your volume and you would multiply by the molar concentration. Okay, so number of moles is, I usually write the molar concentration first, but it doesn't really matter. That followed by the ratio, and the ratio of course comes from the balanced chemical equation. So 1 aluminum hydroxide, 3 nitric acid, or HNO3, and then followed by using the molar mass. And what I get out of that is 5.1 grams. Now, if you want to do 3 distinct steps, no problem. It'll still work. So let's leave you with one. You can try it. We'll take it up in class. We can show it to me, and then we'll find out how much more practice we need. So here's the reaction. Pretty straightforward reaction. I seem to have a thing going for 1s and 3s today. Okay, I'll let you write that down. It's actually going to look fairly similar to the previous one. I'm just going to flip back there for a second. This one, except molar masses are different and the molar concentrations are different. But other than that, the plan you take is going to be kind of similar. Alright, I'm going to leave you with this. We'll talk about it in class. We'll give you lots more practice in class. Don't worry, we're going to have lots of practice stoichiometry, and we'll learn how to use that also when we want to start with a mass and finish with a volume. And it's all the same plan, stoichiometry. Yeah, talk to you later.